Hi students, I'm going to explain one example problem in this video. Let's first read the problem and try to understand it. So the problem says that company XYZ must purchase a machine recently destroyed by an accident. There are two options available. Machine A will cost 60,000 and this machine should last 20 years. The maintenance cost of this machine will be $2,000 per year. Machine B, so the first option is machine A. The initial cost is $60,000 and maintenance cost is $2,000 per year. The second option is machine B. This machine will cost $72,000 in the beginning, and the annual maintenance cost of this machine will be reduced to $500 per year. So this machine is costly, but its maintenance cost is less than machine A. What we need to do is we need to determine the internal rate of return of purchasing machine B. If the company requires a return of 10% on its capital projects, which machine should they purchase? So first we need to determine the internal rate of return, and we need to compare that internal rate of return with the 10% return that the company requires on all its projects, and based on that we need to make a decision regarding which machine to buy, right? So first thing we need to do in this problem is we need to calculate net present worth for both the options. So I have written a formula here. Net present worth of machine A. Let's first focus on that. Net present worth of machine A. Net present worth is basically we are considering all the cash flows, the positive as well as negative cash flows over the lifetime of the project. In this case, the machine, and then we are all those cash flows we are converting into the current value, the net present worth of that project or that machine. So in this case, the first cash flow is a initial cost that we are going to incur for purchasing machine A, right? So that is a negative cash flow. We need to spend $60,000. So that is minus 60,000 there, which is in year one. Then after that we need to spend $2,000 every year for maintenance of machine A. So minus, again, negative cash flow. We need to spend money, $2,000, right, per year. But we need to calculate the present worth of this cash flow. I mean, the $2,000 we are going to spend for 20 years. $2,000 each year. We are going to spend that amount for 20 years. So that particular cash flow for 20 years we need to convert to the present worth. So that for that we need to use this formula, as we all know. P given A, that means A means the annual cash flow is given, right? A is for annual cash flow or annual expense in this case. Based on that, P given A, P means present value. We need to find out present value of that annual cash flow. I is the interest rate and N is the number of years, right? So that is equivalent to minus 60,000 initial cost minus 2,000 multiplied by P given A. We don't know the interest rate. We need to find, that is what we need to find out, the internal rate of return. So that I will write, I will keep it as it is I%, and the N is number of years, which is 20 years. So I put 20 years there, right? So that's my final expression for net present worth of machine A. Now we need to do we need to calculate the net present worth for machine B as well. So machine B, in the beginning we are going to spend $72,000. So that is minus $72,000. That is already the present value, right? Because we are going to spend that money in first year itself. Then over the next 20 years we are going to spend $500 every year for its maintenance. So that cash flow for 20 years we need to convert it to its present value. So again, using the formula, we have been given A, which is annual cash flow, which is negative because we are spending the money. given A, we need to find out P, present value, right? So P given A, I interest rate, comma, the number of years. So that is again minus $72,000 minus 500 multiplied by P given A, I we don't know, and 20 is the number of years. Now to find the internal rate of return, we need to equate these two expressions, and net present worth for A and net present worth for B. We need to equate these two. So let me write down here NPWA is equal to NPWB. So that is equal to minus that I copy pasted this expression from there to here, and on the right side I have NPW, net present worth for B, right? Then we need to solve this equation further. Minus 60,000, we can take this 72,000 on the other side. So $72,000 minus $60,000 is $12,000, and the 2,000 minus 2,000 minus 500 is minus 500, which if we send it to the other side, it will be plus 500. So minus 2,000 plus 500 is minus 1,500. P given multiplied by P given A, I person, interest rate, and number of years 20, right? That is equal to 0. Basically we have transferred both the terms, to the other side. Then solving it further, we get this P given A value, we get 8, right? That is the value of P given A, 8. Now we need to find out the interest, the IRR, which is internal rate of return, or I here, right? At I%, P given A is 8. That we already calculated, right? P given is 8. Now we need to look at the compound interest tables at the back of your book, which is in Appendix C. The table starts on page number 595. I don't have access to book right now, so I'm going to show the same tables on this website here. I have a compound interest table website, right? We know P given A, which is 8, and we need to find out interest rate. We also know the N is equal to 20 years, so we need to find out the I. So I'm going to scroll through the tables, and if you scroll through the table, you will see at 10%, like for example, if let's say if I just look at the table in which I is 4%, we know N is 20 years, right? And P given A value is, at that point, P given A value is 13.590. So this is not correct because our P given A value is 8. So we need to keep scrolling until we reach, we get closer to the 8. So I'm going to keep scrolling, and as you can see at 9%, let's take a look at the 9% interest rate table. Okay, 9% here. Again, N is 20. At that, I need to find out the P given A, which is 9.129. It's closer than the one that we previously looked for, but still it is not 8%. So we need to keep scrolling. At 10% interest rate, and is 20 years, we are getting P given A is 8.514. So that's very close. That's very close to 8. We still keep scrolling. So this is at 10%. This is a 10% interest. If we keep scrolling, we get a 12% interest rate table. So there at N is 20 years, P given A, which is this value here, is 7.469, right? 7.469 at 10. So at 10% interest rate, P given A value from the tables is 8.514. At 12% interest, P given A value from the tables is 7.469. That means I should be between 10 and 12%, right? It is, we want P given A equal to 8. So that is between these two values. So I should be between 10 and 12. Now we can use interpolation to find out exact value of I. Interpolation, all of you should be familiar with interpolation. If not, you can go to Wikipedia, and this is Wikipedia linear interpolation. You have a formula there. This formula basically we are using to find out the exact value of I. So I will explain it here. Basically, we have three data points, right? I percent, 10%, 12%. So if I do I minus 10 divided by 12 minus 10, I minus 10 divided by 12 minus 10. So on this side of the equation, I have all interest rate. On the other side, I will have the equivalent P given A values. So at I have 8. At 10%, I have P given is 8.514. So 8 minus 8.514 divided by 7.469 at 12%. So 12% here 7.469 minus at 10% we have 8.514. So that's the equation for the interpolation. We need to solve this equation for I. So you will see as the solution steps, and in the end, after doing all the calculations, I get I equal to 10.9837. 10.9837. So that is internal rate of return. This is our answer basically. I is equal to 10.9837. Now we need to decide whether we should choose machine A or machine B. If you go back to the problem statement, it says company requires a return of 10% on capital projects. Since our return is 10.9837, so the actual return is higher than the required return. So we need to choose the machine that has a high initial cost, which is expensive in the beginning. That is machine B. Choose machine B. In case if our actual interest rate would have been less than 10, then we should go for the less costly option in the beginning. Okay, so this you need to remember this for all these type of problems. When you calculate your actual internal rate of return, if that is less than the required rate of return, then you need to go for the less expensive option in the beginning. If your internal rate of return, actual internal rate of return is higher than the required rate of return, which is the case right now, then we need to go for the option that has a high initial cost and low annual expenses. So in this case, that is machine B. So we are going to choose machine B. So that's basically answer for this question.